In this video I'll quickly go through the solution to this one because I think it's a little bit different in that it's got integrating a log. Now if you saw integration of a log, you would say I can't do that, but the fact that it said let u equal log x is indicating that we're going to do this by substitution. Now you can see that it's a definite integral, so we'll get to practice changing our limits again and just looking at something a little bit different. So if u is equal to log of x, and we can see that we're wanting a dx, if we consider du dx, differentiate this function u with respect to x, we get 1 on x. So we know that if we cross multiply there, dx is equal to x times du, or we don't want that. What we would actually like is that du is dx over x, divide both sides by x, because if we look at this, this is actually the integral 1 to e squared of log of x times 1 on x, just separate that x in the denominator out, and times dx, which could be written as 1 to e squared of log of x times dx on x. Now, using our substitute, and there's the dx on x, which is what we want. So we've got subbing in our u now, and u is log of x, so that can be entirely replaced with u, and the dx on x can be entirely replaced with du. Now all we're left to do is to find the appropriate limits. When x is equal to e squared, we would have u is equal to the log of e squared, which is 2 times the log of e. The log of e, what's the power you raise the base 2 to give e, which is 1, so that's 2. So we're going to go u is 2, and when x is equal to 1, u is equal to the log of 1. What do you raise e to get a 1? You raise to a 0 to get a 1. So we're going from 0 to 2 in terms of u. Now, this is all set up nicely. We can work through to the end just in terms of u here, because remember, we've adjusted our limits to u values and we need to get a value answer. So we don't have to revert back to x's, we can stay with u's. Add 1 to the index and divide by the new index, and we're going from 0 to 2. So we'll sub in 2, 2 squared on 2, subtract 0, and we've got 2.